Testing, testing. All right, guys. Looks like you can hear me. Let's drop my clipboard. It is 1:30. We're going to go ahead and get started. I'm going to start a little slow because there's still quite a few people that haven't shown up. So there'll be an occasional pause here and there. But today what we're going to go over is one of the machines we have available in the shop. Some of our technology types of machines like lasers and CNCs and stuff. This is our large 4-foot by 8-foot CNC. It is a 3-axis machine. What I mean by that is it's got an X-axis, a Y-axis, and also has a Z-axis. Okay. Basically what it does, it's really a machine-controlled router. Okay, so a handheld router can do a lot of different things depending on the bit that you put in it. And let me zoom over here. Let me zoom over here and show you what I'm talking about. Come over here, you little guy. So this is our station for this machine, and this is some of the bits that we have available to us on these machines, and these bits work in all of our CNCs. There's basically a really wide assortment of bits that we use. For example, there are things that we use for carving letters and things like that. There's a little V bit. This is a 60-degree V bit. Okay. There's different angles on some of these V bits. This is another V bit. This is a 90-degree V bit. There are bullnose bits similar to this. Basically got a round tip on it. You can kind of see the round tip there. I'm trying to look at the screen at the same time I'm showing you so that I can tell if you can see. And every time I move, it's backwards from what I see in the screen, so I don't get it. There are straight cutter bits like this, just a simple 3/8" half or straight cutter bit. And then you get into the more expensive type bits. This is actually a spiral down cut bit. Solid carbide, really sharp, not cheap at all. I think this is about an $80 bit. And then I have the bits that we use for our guitars. And the reason these things are so expensive is, and I'm not sure, I know you guys don't understand this stuff, but if I can give you an idea, if you look at the cutters on this, they go up and to the left like this. This is the cutting edge right here. There's 2 of them. There's another one right here. Okay. So this is what's called a spiral down cut bit. Okay. Up to here. All right. Then if you look at the very end of it here, you can see there's another cutter that's going up and to the right. So this is what's called a compression bit. What it is, it's an upcut at the first 1/4 inch of it. It's a down cut the rest of the way. And the reason for that is because a down cut bit, excuse me, let's go back this the other direction. An upcut bit will leave fuzzies on the upper surface of your cut. So let me go back over here. This camera will go where I want it to. Okay. So basically we use this for cutting out guitar bodies and things like that, at least for some of the larger parts. But basically when this bit is in the material, if we use solely an upcut bit, then there'd be a lot of fuzzies and tear out on the upper surface of this. The down cut portion would leave tear out and fuzzies on the back surface of this. So basically what a compression bit's supposed to do is reduce the amount of tear out and fuzzies on the upper surface where the bit enters the material, as well as on the bottom surface where the bit exits the material. Because when we cut a guitar body or something like that out, we're cutting all the way through the material and into the bed. You can see some of the cut marks left here from previous bodies. This is a setup so that we can do 3 guitar bodies at the same time. We bolt them down into place. And one of the reasons we have them very specifically bolted into place is that we have to be able to flip this body over and mill the back of it. And that requires that we flip it on the exact center of its axis. So in other words, I can undo these 2 bolts, flip it over, screw it back down, and we can do the back side of it, the electronic pocket and electronics pocket and things like that. So a lot of different bits to choose from, and the bits have very, very specific uses. These are the same bits we can use in a handheld router. Most of these bits, though, are not the type of bits that we'd use in a handheld router. For example, this is a surfacing bit. a spoil board surfacing bit. This thing's a monster, man. It's 2.5 inches across. It weighs at least a pound or more. There's no way in heck I would ever put something like this in a handheld rodder. You'd never be able to control it. So let me get a couple more people in. I saw Macy show up, but she bailed. Okay, so this is basically the setup we use for our CNC. Yes, there's a lot of large bits here, but there are also a lot of very small bits as well. For example, this is, let's see if I can show it to you. This is an 1/8 inch diameter spiral down cut bit, tiny little guy, okay? And they get even smaller. This one's actually snapped off, so it's not really helping much. But this was a 1/16 of an inch diameter bit. We even have a 32nd of an inch diameter bit. Really, really tiny. It's like a dentist drill bit. I basically keep those locked up in the office so they don't get dropped or anything because they break really easy. And we use those little bitty bits most of the time on our smaller desktop CNC for things, a lot of times on guitars and stuff like that. So this is a fretboard that we used for testing to do some work on it. This was a girl that did a themed guitar that was, it was a Disneyland, Pirates of the Caribbean, no, Haunted Mansion theme, okay? And so each one of these little guys here, let me turn this a little bit so I can get it closer, okay? So each one of these little guys, okay, these are the fret dot locations. 3rd, 5th, 7th, 9th, 12th, 13th, 15th, 17th, 19th fret location is where you put fret dot markers. And each of these little guys is a bat. I don't know if you can see it, but it's the shape of a bat, all right? And then these numbers down here, this 999, I guess is on the door as you walk into the ride or something like that. It's significant in what it is. So what we did, basically, this was a test run. What we did was when she did the actual fretboard, we did all the bats and we poured black epoxy in the bat locations. And I think we did blue epoxy in the 999, but I know we did a really cool little inlay at the top of the headstock that was blue epoxy. So you can get some really, really fine, if you look at those 9s in there, imagine the size of bit it takes to get in there and get those tiny little numbers in there. It's pretty amazing, okay? So I'll get them on there, Sam. Thank you for telling me. I'll double check that and see what's going on with the modules. So basically the way a CNC works, or you guys have probably all had a math class in what, 5th or 6th grade or something like that, that was graphing, okay? It was graphing points along an X and a Y axis, okay? So we're gonna take a look at that. That's how this thing, that's the basis for this machine, really. Get on the right one here, okay? And it basically just runs on an X and Y axis, okay? So you guys should know, or I would hope you'd know. So negative X is this direction, okay? That's our negative X axis, okay? Positive X is just the opposite direction, moving away from me, okay? Here's our Y axis, that's positive Y, all right? And this is our negative Y axis, this is negative Y, okay? So using those that coordinate system, that Cartesian coordinate system, can take us anywhere on the surface of this 4 foot wide and 8 foot long bed we want to go. And it's a simple matter of numbers that tell this where to go. We also add on this machine a 3rd axis, and that's the Z axis, and that moves up or down. So that actually gives us the ability to do 3-dimensional carvings and things like that, raised lettering, stuff like that, shapes, the seat pan on a rocking chair, things like that, all kinds of different shapes. And what this uses to tell it where to go is what's called G code. I'm going to get this back over here on the screen so you can see it. At least I think I am. Maybe I did it wrong. There it is. All right, so on this screen is the control software for this machine. Okay, this yellow box up here is how I can physically control the machine, or can I use the keypad, the number pad. This does the same thing that the other one did. It moves our axes left and right, positive, negative X, positive, negative Y, and positive, negative Z. Okay, so this is telling me some information here. This tells me the current coordinate location of the tip of the bit. And then this green field here, I don't know if you can see, you probably can't see my cursor, but this big open green field here is where the G code is shown. So what I want to do right now is I'm going to move this over to its current 0, 0 location. In other words, I've got a little piece of material. Let's call it back over there. Got a little piece of material that's mounted to the tabletop right here. What we're going to do is we're going to have this machine carve something on the lower face frame rail for the nightstand we're building. Okay, and this is what it's going to carve. If you guys can see that. All right, it's going to simply carve that out of a piece of pine. So that's a 3 inches wide by 13 inch long piece of material, and that will end up being the very bottom piece of the face frame. Okay, so a couple things we have to do to get ready to use the machine. First of all, we have to have more material ready. It's got to be consistent thickness, and we have to know exactly how thick it is. We also need to figure out how we're going to set it up. Where do we want our X0, Y0 to be on this? Okay, so I've set the X0, Y0 right over here, and my fat arm's in the way. I'm going to come around the other side. So I've set the X0, Y0, what's called the home position. All right, everything this thing knows is going to work off that home position. It's right here on this corner, right down here, okay? We also have to have this affixed to the surface somehow. It's got to be stuck to the surface, because we're going to have a bit that approaches this material and actually cuts into the material. And it's a moving bit, so it will move the material if it's not fixed down. We have a lot of different ways to do that. We do it with the bolting system for the guitar bodies. We use double-sided carpet tape, excuse me, to hold things down when there's not going to be a lot of real harsh work done on it. We've got jigs that we can clamp stuff into it. We've used clamps. But what we're using right now is what's just basically called a wedge system. There's a piece of scrap material that's screwed down to the surface of the machine. And then in there, we've got these two little wedges, okay, little scrap wooden wedges that I place the pine, and then I'll show you how this works when we take it out. And then I tap a wedge this way, I tap a wedge this way, and they come together and hold this. I mean, it's in there really good. It's not going anywhere. Okay, so our material is affixed to the surface of the bed. I've already gone through the setup of telling the machine where the physical surface, top surface our material is. There's a little touch plate that you put under the bit, and then the machine will come down and touch the bit, and it tells the machine where the surface of the wood is. I don't want to be carving up in the air somewhere up here. That wouldn't do any good. I want to be able to carve where I want. Hold on, I'm checking somebody in here. And I've also told it where our XY home is, where our X and Y0 is. So I'm going to send it to its home right now. The nice thing is, once we've set this home position, I can go anywhere I want. I'm going to back out of this so you can see it. Excuse me. I don't know. I don't remember which one's which. Come on. There we go. Okay. So I'm just going to click on it to send it to its home position, and it will automatically find its way back to this corner of the material. And you should be able to see that. That we're sitting right here over this corner of our material right here. Okay. So that's where we're going to start from. All right. So let's get the code up here so you can kind of see what that looks like. That's the wrong one. That's the right one. Okay, so all we really have to do is I've set the file on the desktop here. It's sitting in a little folder up here. Okay, file, I'm going to load the part file. This is the one we want. Open it. Now, What this is asking me is everything we have set up so far correct? Okay, I can change some basic things around here. I can make some slight changes if I want to, but on a project such as this, it's not that big a deal. So I'm going to hit enter. And what you're looking at here is this machine's going through the first part of code. Okay, so before I started, I want to show you guys something. That initial information that was flying by there basically was just telling it the file name, the type of tooling it's being used, what kind of speeds and feeds it's being asked to run at, things like that. But now we're in the meat of the code. And basically what that is each individual line item, okay, is telling this machine where to go. It's got an X position, a Y position, and a Z position. It's telling it where to go. In order to make these 7 letters, 7 simple letters, there are over 2,000, well over 2,600 lines of code to get this thing to do it. Okay, so we're going to go ahead and get this camera back over. If I get it to the right place, and we are going to run this guy, and let's see what happens. All right, it doesn't take but a couple minutes for the file to actually run. There's the W. So just to do the weed, that was just under 1,000 lines of code, about 800 lines of code, telling this machine where to go. So I'm going to answer some of these questions here. So no, you do not write the code yourself. Basically what you do is you design in another piece of software that works for this machine. You design what you want to do, and then it writes the code, okay? Another question was, it goes slow and then super fast. That same question was asked last period. It's called ramping. Most of the time it goes straight lines and things like that pretty quick, but the ramping is a really complex animal based in the program that I haven't completely figured out yet. But when it's doing the tips of letters, and you can see it raise up, it raises up and then lowers back down. I'll show you what that's accomplishing when it does that. It does that slower. You have control of all these different things that it's doing, how fast it does things, how slow it does things like that. But it's still, CNCs are still an animal that sometimes they work the way you want them to, sometimes they don't. You can actually start these in any portion you want. I can sit here and say, well, I want to do the W first and then the G last, and then I can make it go where we want. It's just going from one end to the other end. So it's just a question of how it goes about its job. Let's see. Yeah, so basically we'll show you what we got. Let me get this out of the way so I can get to it. And a little bit. And I'll show you the wedge setup we've got there. And let me get this up out of the way. And we'll move this gantry. So that didn't take what, but a couple minutes, something like that, to carve that out. think. Hammer. That's all it is two wedges, right? You tap them together so they close up. I don't know if you guys can see that or not, right? This is affixed to the table. We add. There's our job, okay? That's what we've accomplished. All right, that took a few minutes to do. Imagine what it would have taken hand carving and how it might have turned out. Okay, so you can't really see it too well because the light is really terrible here. Let me see if I can zoom in, see if it'll zoom in anymore. So when it was raising up, what it was doing was getting these sharp points on the end of the letters, right? Basically, when you see it wider and get skinnier, that's the bit lowering, raising, lowering, and then as it raises, it finishes off that little edge, okay? Yes, elevation or the Z-axis is depth of cut. And in a job like this, which is called a V carving, it uses a V-shaped bit, okay? The depth of cut is determined by the distance between two lines. So if I have two lines that are 1/4 inch apart, okay, it's gonna go pretty deep because I don't know if I can explain this. It's much easier to explain this when you guys are here, but see if I can show you here. So we've got, this is an example bit. I'm going to see if I can get this on me so I can kind of explain this so you guys can understand it, if I can. Go around this way. Is that the right way? All right, so here's what we've got, okay? This is the V bit right here. This is a 60-degree V bit. I'm trying to look at it while we're doing it, okay? So you can see this bit, right? This is not working. I wish you guys were here. Okay, it's going to raise up as it gets to two lines that are closer together. It's going to, as the lines get further apart, right? It lowers the bit. So the width, the depth of cut is determined by the distance between two lines. I know that doesn't make any sense, but you can get a pretty good idea of how nice of a job this thing does. I mean, that's, you know, in a matter of minutes, just simple carving, okay? Now, our laser system that we have here works on the same premise. It works in the same way. It also has an x-axis, a y-axis, and a z-axis. But the difference is, what I really enjoy about the laser is that there's not a cutting tool that actually touches the surface of the material. On the CNC router, you have a bit that has to touch the material to do the work. That means that the work has to be affixed to the table. It has to be held down to the table somehow. On the laser, that's not the case. There's no cutter that actually touches the material. It's a laser light that burns into it. So you can set a piece of material anywhere on that bed, move it however you want. It's really easy to reposition material and things like that. So, but it doesn't have the capabilities that a CNC has in regards to three-dimensional carving and things like that. So there's drawbacks to both and there's benefits to both. Angle cuts on the CNC aren't done unless it's done around the edge or with a V-bit on the interior. We do have a 5-axis CNC that has an X, Y, and a Z axis, and also has a secondary A and B axis that allow you to approach material from, let me zoom out on this. I'll show you what I'm talking about. Okay, so we have a 5-axis. So right now, when we do something, okay, we can only approach the material on this machine. We can only approach the material from the top surface, okay? We cannot come at it, I'm wrong end. We cannot come at it from this direction or this direction. The 5-axis CNC gives us the ability to rotate this bit this way and rotate it, once I get there, this way as well. So in other words, our 5-axis CNC can approach material from the ends and, Jesus, it's hard to do, and from the edges, okay? This one can't. That other machine can angle at something in this direction instead of just straight up 90 degrees. I'll show you something here. I'll show you something real quick that was done on the CNC that's 3-dimensional. Okay, maybe this will help you understand what it's capable of. So we've done quite a bit of three-dimensional stuff here. This is an example that we did. One of the first things we did on this machine when it came to three-dimensional carving. I'll move the camera over there so you can see it. So this is an example of three-dimensional carving, where the Z-axis is used as part of the design. Okay, so this is actually carved straight out of the flat face of a piece of alder. This is right off the machine, no sanding, no nothing. Let's see if I can show you a little better what I mean by three-dimensional carving. So instead of removing material, see, this is a, there's terms, I can't think of the terms right now, but so instead of removing material to create the lettering, right, it removes all the material except the letters. So when you look at this, you can see it's actually raised off the surface of the wood, right, instead of recessed into the material like this. So on this one, on this thing, right, we removed material to create the letters, okay, really quick, no problem. On this one, we had to literally, it went back and forth over the entire surface. Then when it got to a letter, it will raise, go back down, raise. In other words, that's how it created this three-dimensional look. So this is all raised lettering. I hope you can see that with the shadows on it.
Can you bring it closer to the camera?
Yeah, let's see if we can. So can you guys, that should, you feel to see that, right?
Yeah, that's good.
You know what I mean?
Thank you.
So that's what I mean by the raised lettering. Okay, so that's a three-dimensional approach to creating something on the machine. It's really pretty phenomenal what it's capable of doing. And the finish that is left on this after a pass on this machine is actually pretty good. You can program how close together the lines are on this thing, but that right there is straight off the machine, really doesn't require any sanding, anything like that. It's really pretty neat. Yeah, it does look kind of like it's bubbling out type of thing. It's like raised out of it. So there's a lot, and the cool thing, what we'll do with this sign down here, if I have time, what I would usually do with something like this is we could just leave the letters in there like that, or what you do is you take and you just all willy-nilly, you just kind of slather paint in there, like glue paint or something like that in the letters, right? Get it all in there, and you'll have a mess on there and everything. It'll look terrible. But once the paint dries, then you just sand this surface. I keep doing this, and I'm trying to look at the camera at the same, or look at the screen at the same time. I'm going wrong. Okay, and so once you get that, all that paint in there and everything, you're gonna have a mess, right? There's gonna be paint everywhere. Okay, but once it dries, then you sand this surface, and the paint is gone from the surface of the wood, and it stays in the letters. So you can have painted letters, things like that. We can do inlays with things like this. You can inlay individual letters of a different type of wood, stuff like that. Yes, yeah. So Kevin, you're exactly right. When it comes to an inlay setup, basically what you're doing is you're cutting the letters out of one piece of material, and you're cutting basically a photo negative of the other pieces out that will drop right in here. Okay, we actually have, I don't know if you guys have seen these things before, but we did what's called a dovetail key on a student's piece of furniture. It's basically this, it's shaped like this, these little keys, okay, that are shaped like this, that go across a split in a piece of wood to keep it from splitting. And this was a storyboard that we had to figure out the spacing for it. Every single key here is like, this one's 125 10,000ths. This next one's 25 thousandths, 175, 15,000. So we have all these different size recesses that we want to make sure the keys that we cut fit perfectly in there. So we did different sized recesses to try their fit with a key. So we've done inlay. We've done quite a bit of inlay on guitar fretboards and things like that. This was another test. This was on the laser. It hasn't been sanded, but you can see the Vikings logo and stuff like that. This was done on a laser. Usually the smoke would be gone after we sand it and everything. But the detail you get on the laser is a higher level of detail than the CNC. Not to think that the CNC can't get good detail. Yeah, there's some really cool stuff that can be done with these. Absolutely fantastic stuff. We're going to do this. The CNC part will be on the nightstand. Tomorrow, what we're going to do is we're going to assemble and mount the face frame on the nightstand. And then we're going to get ready to do the top. And on the top, we'll do some laser work on the top so you guys can see the laser function and things like that. And I'll try to come up with some sort of design for the top that doesn't look too lame. And we'll get that set up. So you guys have any questions at all about the CNC or anything like that, or what it's capable of, or how it does it, or anything like that? Any questions at all, please ask, because it makes me feel like I'm not alone here. Right now, I feel like I'm very, very alone here, and it's boring. Okay. So tomorrow, like I said, we'll get the face frame assembled and mounted. There will likely be a quiz tomorrow, either tomorrow or Wednesday. I try to have 1 to 2 short 5-question quizzes each week, just to keep you guys on your toes. You should know that progress reports come out today or tomorrow. They go out. I recommend wholeheartedly that you guys check your grades from time to time, and please check your grades in PowerSchool. Don't go by what it says in Canvas. Canvas is well, it's kind of whopper-jawed from time to time, but what's in PowerSchool should be accurate. So if you want to look at PowerSchool, and if you think there's something that is incorrect or has been entered wrong, you need to let me know. I can't fix it if you don't tell me if there's something wrong in the grade book, okay? So please take a moment and look at PowerSchool and look at your grades in PowerSchool to make sure everything's entered properly. I want to make sure everything's correct, okay? And I'll get it fixed if you let me know. All right. So do me a favor, make sure your name is in the chat window. Thank you for being here. Take care of yourselves tonight. I look forward to seeing you tomorrow, and we'll get some more work done in the shop tomorrow and try not to be too bored. Take care of yourself, folks. Bye-bye.
It's not really a question, but do you have any other examples of the bubbled out
Yeah,
board?
let me look real quick. Hang on for a second. I'll see if I can find it. Okay, so there's another one I was looking for, but I'm not sure where it is, and I could take all day trying to find it the way my brain's working right now. But here's a couple, okay? So this is just another one that's basically, okay, basically the same as that last one. All right, you can see the raised lettering maybe a little easier here on this one. Okay, this is just a basic, that was just a mess around with it and try it. Here's another one that's kind of interesting. This is a street address sign, right? So this is a texture that is one of the available, the program that you design in has all sorts of textures and things like that available, okay? So basically what this did was it removed material revealing the texture, all these wavy lines, and then revealing the street letters too. So you can kind of see how that's raised. So that's yeah, actually, you know, I hope you guys continue to take the class here when we come back. And I'd really like to have somebody that's a freshman or a sophomore start to get really good on these machines and help out with them. You can actually see this was a generated texture. You can see the repeating shapes that are all, you see those 4 humps and they repeat. So you can actually, we've had people take, like, for example, I'll show you this real quick. This little carpet that's sitting on, whoops, on top of this cart, okay? This little green carpet thing. You could take a picture of that, convert it in this program, and it would use that as a texture. In other words, I've seen people take pictures of carpet in hotels and things like that. And then there's a program called a tracer that will trace any of those patterns or textures and create your own textures and stuff. So yeah, there's some pretty neat, you know, for some reason I really like this one. This was kind of neat with the texture and the letters and the numbers, I mean, kind of raised out of it. I don't know if you can really tell, but yeah, so there's a bunch that can be done, Sammy. I appreciate the question, by the way. It's nice to get a question once in a while. So, okay. Anything else you guys want to know? I will be here till class time is supposed to be over. So ask away, and I'll help you any way I can. You're welcome, Sammy.